Hello everyone, hope you are just doing well. Tomorrow is your science exam, so I'm just here to just clear a doubt on electroplating and electrorefining. So whatever the process that is written on your book, whenever you are just going through that, I think there is some confusion in understanding the languages or in understanding whatever the things are written over there. Electroplating is one of the simplest process. What I am doing in electroplating, I'm just making a layer of some metal on another metal. Now I have just taken that diagram. Why I have taken that? Because you will see that diagram in your book also. There is a similarity. So that's why I am using that one to explain. So in this case, I am doing the electroplating of copper. That means I am making a layer of copper on the silver. That's why I'm just using the copper metal as an anode and the silver is connected as cathode. As you are using the copper metal as anode and you are going to do the electroplating of copper, so you must have to use the copper sulfate as an electrolyte. Okay, I'm just repeating the total thing. Electroplating is a process by which you are just making a layer of a metal on another metal. Why I am doing this electroplating? To make that metal corrosion free, or I'm just protecting the silver metal here to make it react with the moisture present in air or with the oxygen present in air. Thus, it can be durable and it can be used for so many days. That's why we are just doing the electroplating. Now, here we are going to make the copper plating, or we are going to make a layer of copper on the silver. So that's why I am using the copper as an anode and the silver is connected as cathode. Which electrolyte I am using here? Copper sulfate solution we are using here. Okay, I hope there are two things that are written here as oxidation and reduction. These two things are make you confused. What is oxidation? What is reduction? What the process is going on and how the electroplating is done. Now the process is very simple. Oxidation means what? That means the anode is made up of copper, right? In the process of oxidation, copper is releasing the electrons and it is become positive. That means it is of Cu. Cu is copper. It is released into electrons and it is becoming Cu2 plus. Okay, this is the process of oxidation. Oxidation means releasing of electrons. It is happening in anode. Now, whenever these copper ions, there are a lot of copper ions are produced in the electrolyte. Now whatever the metal portion that is getting immersed with the electrolyte, only that portion, only from that portion the copper ions will be produced. So in the electrolyte there are a lot of copper ions is produced by the immersed portion of the anode, right? So all of the copper ions are positive in nature. They will be attracted by the cathode as the cathode is connected to the negative terminal of the battery. So with the time, all of the copper ions will be attracted and it will make a layer on this silver cathode. By this, we are just doing the electroplating. But in this case, whenever the copper ions are attracted by the cathode, what is happening there? Here it is written as a process of reduction. What do you mean by reduction? That means of gaining of electrons is known as reduction. That means all of the Cu2 plus ions are at cathode. So whenever, I'm just giving you one example, when one Cu2 plus ion will be attracted by the cathode, it will gain 2 electrons from the cathode and it will become copper. So that's why there will be the copper ions become a copper metal in this case. That's why we are able to make a layer over there. With the ions, if only Cu2 plus ions are there, it is not able to make a layer. Whenever it is gaining two electrons, then it is becoming the copper metal. That's why it is making the layer. Okay. I hope the total process is clear. Now, whatever the complex things that are written on your book, now don't remember them, just understand simply the process. Now, which metal is to be electroplated, that should be connected as a cathode, and which metal you are using for the coating, that should be connected with the anode. So here I am just doing the electroplating of copper. So copper is connected with the anode. I'm just making a layer of copper on the silver. So silver is connected with the as a cathode. Okay. And in this case, as I'm doing the copper plating, I must use the copper sulfate solution. If I am doing the zinc plating, I must use the zinc sulfate solution. Okay. Now we are just going to the next process. Now, whenever you will just see these two diagrams, there is a complex thing. In this diagram, the cathode is in the left hand side and the anode is in the right hand side. But whenever you will see the diagram of electrorefining, you will get confused. What is doing here? They have used the anode in the left hand side and the cathode is in the right hand side. I hope this will confuse you most. So you can change this diagram if it is confusing for you. Okay. You can change it in such a way. Suppose this is your container. Now in this case we are just using an electrolytic bath. Now this is your cathode. It should be as thin as possible. Okay. And the cathode is connected to the negative terminal of the battery. I'm just making the cell, and this is my anode. The anode is so much of thicker, right? Why it is so much of thicker? Because electrorefining is a process by which you are able to extract the pure metal from the impure one, right? So here anode, this is my anode, and anode is impure. Impure metal should be connected as anode. Here the pure metal I have connected as cathode, right? So for the electrorefining, you just remember one thing, it is a process by which you are able to extract the pure metal from the impure one. The impure metal should be thicker and it should be connected as anode, and the pure metal should be connected as cathode. That means it should be connected with a negative terminal of the battery. Why I am connecting the pure metal with the negative terminal of the battery? Because it is used to attract all of the positive ions. That's why I am connecting the pure metal with the negative terminal of the battery. Now what will happen? Now suppose we are just using we are extracting the copper metal. Okay, from the impure copper I'm just going to extract the pure copper. So you can say the cathode is of pure copper and the anode is of impure copper. So which I should use an electrolyte? I must use the copper sulfate solution. If it is acidified copper sulfate, then the process will be quick. But if it is only copper sulfate, then it will be a slow process. So it is recommended to use the acidified copper sulfate solution for this case because the anode is greater in size. You have to do the process quick. That's right. Now, whatever the portion that is immersed in this electrolyte, from that portion the same thing will happen in the anode. Which process will happen? Obviously the oxidation will happen. Oxidation means what? That means it will release some of the electrons and it will produce the positive ion. Now let me change the ink. Okay, now in the anode what it will happen, that the copper will release two of its electrons and it will becomes positive. So in the solution, there are a lot of positive ions will be available, right? There are a lot of positive ions will be available. Releasing of electrons, remember, it is a process of oxidation. For both of the processes, in electroplating, in electrorefining, oxidation happens in anode and reduction happens in cathode. Oxidation means releasing of electrons, reduction means gaining of electrons. Okay, so who will gain all the electrons? The copper ions will gain all the electrons. But why they will gain all the electrons? Because all the copper ions are positive, they will be attracted by the negative cathode. So there are a lot of copper ions will be there. And now there should be a question that will come on your mind, from where they are getting the electrons. In the cathode, from where they are getting the electrons. Now the answer of this question that should be, as the pure copper is connected as a negative terminal of the battery, the negative terminal is a source of electrons. So whenever all the copper ions are being attracted by the cathode, after reaching at the cathode, they are getting two electrons easily and they are just forming the copper. For all the copper ions, the same thing is happening, right? So that's why by the time, so all the copper ions are becoming the copper metal, and in this way the cathode is becoming thicker and all the pure copper from the anode is being extracted by this process. The process of extraction of pure copper from the impure one is known as electrorefining. Now after all the metal, all the pure copper is being extracted from the anode, whatever the remaining mixture will be there, that is known as anode mud. Okay. So when all the pure copper will be extracted from the anode, what the remaining will be there? A mixture of other metals. That is known as anode mud. Okay. So after the electrorefining process, the cathode is becoming thicker, because in this case also all the metals are making a layer on the cathode. But it is a process of extracting the pure metal from the impure one. Remember this process. Now if you are having any of the doubt in the process of electroplating and electrorefining, you just tell me. Now one common question that should be, sir, in both of the cases, so we are making a layer. Obviously, we are making a layer in both of the cases, but their application is different. Electrorefining, in the process of electrorefining, you are extracting the pure metal from the impure one. But in this case, there is a similarity that you are making a layer on the cathode, on both of the cases, right? In the previous case, in the case of electroplating, you are just making a layer, thus the silver becomes corrosion free. Thus the silver is not able to react with the oxygen or the moisture that is present in air, right? Their application is different, but in both of the cases, you are making a layer on the cathode. Oxidation, reduction process, they are also similar. Okay, I hope you have understood. Now, if you are having any of the single question, just tell me.